Okay, it's now time to do lesson number 18, the death of stars. And so this is the last lesson that you're going to need to know for the Unit 3 exam. So in your textbook, this is going to be chapter 14 that you're going to need to know. And it would be good if you would have open this chart here. So in your PowerPoints, open up that chart, and so as I am discussing what do all of these different things turn into as they die, then you can be looking at that chart, and that kind of summarizes everything that I'm going to be talking about today. So have that one open. There. All right, so number one, the mass of the star determines all of its other properties. So mass is the number one thing that's going to determine the fate of a star. As you can see, the radius of a star is determined by its mass. The brightness of the star is determined by its mass. The temperature of the surface of a star is determined by its mass, and the temperature of its core is determined by its mass. And then this is how long is the star going to live, and that's determined by its mass. So you don't need to know the formulas, you don't need to know the graphs, but what you should notice is as the mass gets bigger, the star is bigger. As the mass gets bigger, the star is brighter. As the mass gets bigger, its temperature is bigger. But this one down here at the bottom is a little bit strange. It says that as the mass gets bigger, the amount of time it takes to live is going to be less. Now, all of this information, so in case you're saying to yourself, I can't remember that, all of this information is in your HR diagram. Okay, so that if I go on down to here, there's an HR diagram. And so if you look at this, you can see that the low mass stars are down here because there's a number on here that tells you the mass of the stars. And then as you go towards here, these are the high mass stars up here. And then these are the medium sized stars here. So if you look at it, you'll notice that the temperature for a low mass star is low. The temperature for a medium sized star is hotter, and then the temperature of a large star is really hot. So that's following those formulas that we just talked about. If you look at the brightness, that's over here. So the brightness L is on this side, and so the low mass have low brightness. The medium-sized stars have medium brightness, and then the high mass stars are very bright. And then you could also look at the radius. So the radius was the diagonals on this. And again, you will notice it has the same trend as those formulas do. So by having a good understanding of the HR diagram, you really have a good understanding for how these stars behave. All right, so now let's go back up to here. All right, now don't worry about that. So those are just some sample calculations that I did to find out how big would they be, how hot would they be, how bright would they be. And so if you want to look at that, you can, but not going to be on the exam. Okay, this explains why the bigger they are, the harder they fall. The bigger the star, the faster it runs through its fuel, and it's because of its mass. The bigger the star is, the more gravity it's going to have. the more gravity it's got, the harder it has to work to keep gravity at bay, which means it's going to run through its fuel quicker. So here are two objects, a tank that has a mass of 60 tons, and then the Volkswagen that has a mass of 1.5 tons. Look at the fuel tank. So this one has a huge fuel tank compared to this one. But this one burns through its gas faster than this one because it has to push around all that weight. So it's very similar. Okay, let's take a break. When we come back, let's start with the very small stars and find out what do they turn into.